All right, so to pick up where we left off with evaluating functions, there's something called a composition of functions. So for our first one here, let's just let f of x equal 3x plus 5 and g of x equal x squared plus 7. Okay? So first up, you might see something like this. I'm going to ask you to figure out f of g of, let's go with 3. So what that means is we're going to work away from the inside out. So first up, I'm going to have f of g of 3. So g of 3 is going to be 3 squared plus 7. So that means I get f of 9 plus 7. So now I'm figuring out f of 16. So now I'm kind of right back to where I started here. I'm figuring out f of 16. Got a brand new problem here. So that's 3 times 16 plus 5. 3 times 16 is 48. 48 plus 5 is 53. All right. So that's how those work. Again, you're working your way from the inside out here. All right, let's do a different one here. Let's do g of f of negative 4. All right, and just for reference here, f of x was equal to 3x plus 5, and my g of x, is equal to x squared plus 7. So for g of f of negative 4, we got to first figure out f of negative 4. So it's 3 times negative 4 plus 5. So now I have g of 3 times negative 4 is negative 12 plus 5. So that'd be g of negative 7. So again, starting right back to where I was, g of negative 7, we got negative 7 squared plus 7. So that's 49 plus 7 is 56. Okay. So again, you're just working your way from the inside out on these. Keep things organized. We'll do the best we can there as far as those go. But it's all about just trying to keep your problem organized. So let's do 2 more of those. All right, so let's go with f of x equals all right, a little bit longer problem here. And let's just start off with, for a here, let's go f of g of 3. So first thing, again, I'm figuring out g of 3. So g of 3 would be negative 2 times 3 plus 7. So that means I have f of negative 6 plus 7. So that's f of 1. So now I'm right back to the start. I've got to figure out f of 1. So that's going to be 1 squared minus 4 times 1 plus 3. So that's going to be 1 minus 4 plus 3. So that's going to be negative 3 plus 3 is 0 for a final answer. All right, and then last one where we're doing the composition of functions here, we're going to do g of f of negative 4 here. So that means we're going to have g of, we got to put negative 4 into f there, so it's going to be negative 4 squared minus 4 times negative 4 plus 3. So So it's going to be g of 16 plus 16 plus 3. So it's going to get me down to g of 35. So g of 35 then, oops, it's going to be negative 2 times 35 plus 7. So it's going to be negative 70 plus 7 is negative 63. All right, last thing I want to go over then is just some graphs of functions here. So I want to go, there's three types of graphs I want to go over with you. So first up is just our basic linear function. Again, all these, you can pick whatever x values you want, okay? So your domain is all real numbers. So it just means you can pick any numbers you want. So let's go with -1, 0, and 2. So that means I'm going to have negative 4 times negative 1 plus 5. So it's going to be 4 plus 5 is 9. So -1, 9 is up there. And again, we're just getting some points here. This is a continuous function. There's infinitely many points on here. I'm just picking out 3 so we can make a graph here. So our points are -1, 9, 0, 5, and 2, -3. So on these linear functions too, your domain is all real numbers, so I can substitute any number I want in. And this line goes on forever up, on forever down. So we talk about the y values you could get. Your range is all real numbers as well. All right, so next up we're going to graph this absolute value function. All right, so if we put 0 in here, we're going to get 0 minus 4 is -4. So I got the absolute value of -4 is +4. Absolute value of -2 is 2. 6, you're going to get 2, and 8, you're going to get 4. So your graph. All right, so again, when you talk about domain, you want to think, what are the x values I can put in here? You can put any x value you want in, all real numbers. But when it comes to the range then, the smallest y value I have here is 0, and then my graph just keeps going up in both directions. So my range is y is going to be greater than or equal to 0. All right, so we got an absolute value function. The domain is all real numbers, which means I can substitute in any number I want. And my range is y is greater than or equal to 0. And the last one I want to do here is a quadratic function. So remember, whenever you square a number, it's going to be positive. So that's I got positive 9 there. It's negative 3 times negative 3. So first up, I got negative 3, 5. And then negative 2 squared minus 4, that's going to get 4 minus 4, so that's just 0. Negative 1 squared minus 4 is going to be 1 minus 4 is negative 3. 0 squared minus 4 is 0 minus 4 is negative 4. 1 squared is 1, so I got 1 minus 4 is negative 3, and then we go 0 and 5. All right, I'm just going to skip the last two there so I have some space to write some things, but my graph is going to look like this. We had 0, negative 4. So as far as your domain here, it's going to be all real numbers. Okay, you can substitute any number you want in here. For the most part, not till we get very late in the school year will we get a function where you got to worry about the domain. But as far as our domain with these functions go, you can substitute in whatever you want. The range can differ though. For my range, my smallest y value is negative 4. Notice my graph comes down, bounces back up. So the range is y is greater than or equal to negative 4. All right, so those are your main ideas with this. You're really just evaluating functions, seeing what you get on the graph, domain, think about what you can put into a function, range, what you get back out.